Hey there everyone, today we're going to have some fun exploring how we can find all the odd numbers in an array. We'll take a look at the time and space it takes to do this. Let's jump right in. Using the array, let's identify all the odd numbers. In order to effectively identify and extract all the odd values from a given array, we will proceed with its following algorithms. This is the algorithm explanation along with its Python code. First, loop through each number in the array. Second, check if the number is odd using the condition num modulo by 2 is not equal to 0. Lastly, if it's odd, we store or print it. Now, let's break down the complexity analysis. When analyzing the performance of an algorithm, we focused on time complexity. This is where how the execution time scales with input size, and also the space complexity. This is how much additional memory the algorithm uses. In this code, we define a function that iterates through the array, checks each number and stores the odd values. Let's proceed by breaking down its time and space complexity by each line of the code. In the first line, we assign big O1 time complexity based on function definition. On the second line, we assign big O1 time complexity based on the initialized empty list. In the third line, we assign big O(n) time complexity based on the loop through array. In the fourth line, we assign big O1 time complexity per element based on the check the condition or the condition statement. In the fifth line, we assign big O1 time complexity per operation based on the appendment of the list. On the sixth line, we assign big O1 time complexity based on returning the result. In the seventh line, we assign big O1 time complexity based on the new assigning of the array. In the eighth line, we assign big O(n) time complexity based on calling the function. Lastly, we assign big O(n) time complexity based on the printing of the results. Summing all up, we have 1 plus 1 plus n plus 1 plus 1 plus 1 plus 1 plus n and plus n, with a total of time complexity 3n plus 6. Neglecting the higher and lower growth, we finally have a time complexity of big O notation n, a linear time. In terms of space complexity, we have two categories. First is linear time, second is the constant time. If all numbers are odd, we store elements in a new list. Consequently, we have the linear space complexity of big O1 notation. On the other hand, if we only print the odd numbers instead storing them, we have a constant space complexity, which we have big O(n) notation. And that's it. I hope you enjoy and learn something from this video. Thank you for watching.